Welcome to today's lesson on reducing fractions. In this lesson, we will take complicated fractions and find easy ways to reduce them to help them make more sense and be much more easy to use and manipulate. So first, by definition, a fraction is in simplest form term or lowest terms if the numerator or the denominator share no common factors between them. If two numbers share common factors, they can be reduced and made smaller by finding the greatest common factor. So in this case, if we found that, the fraction is in lowest form. First easy example to think about would be 10 over 20. It can be reduced to 1 over 2. Although this is a very easy one to see, and we still want to make sure that we're able to visualize it. Imagine a 10-slice pizza with 5 slices being present, and that easily being also represented as a 2-slice pizza with 1/2 still there. Both of them would mean 1/2. We go back and think about the idea of the greatest common factor and how we can find that between two numbers. So we take the numbers 12 and 18 and begin by finding their greatest common factors. We can start off by making a factor tree of 12. And we think of 4 and having two separate factors of 2 and 3 remains a solitary factor there, and 18 as having two factors of 9 and 2. 9 also being able to break down and have factors of 3 and 3. I can match up a 3 from the 12 and a 3 from the 18, and 3 is one of my factors. And I can take a 2 from each number, and 2 is my other factors. By multiplying both of these, I get my greatest common factor of 6. With this greatest common factor, I will be able to then utilize this to then reduce those fractions. Another visualization would be to think about those same 18 circles and being able to say, well, if I group 12 of them and I take those entire 12, how could I represent this in a much easier way rather than always saying 12 over 18? So with our first example, we'll take 12 over 18 and then reduce it by using our greatest common factor, which was of course 6. In doing this, I take the fraction 12 over 18, and I will use 6 and divide both the numerator and the denominator by that GCF by 6. 12 divided by 6 gives me 2, and 18 divided by 6 then gives me 3. So my fraction is 2 over 3. All I've done was reduce it. Didn't change the quantity, did not change the value. 2 over 3 is the same as 12 over 18. So what do we do when we have a big number like 36 over 48? We can reduce this in pieces and not necessarily worry about having to find the one number that reduces them right away. So in example 2, I'll take 36 over 48, and I'll first think, well, what number do I know goes into both of them? First number that comes to my mind would be 4. So I will simply divide it by 4, even if it means I'm not automatically done with the work. 36 divided by 4, 48 divided by 4, and as I evaluate the top, 36 divided by 4 gives me 9, and 48 divided by 4 gives me 12. Now I look at that fraction 9 over 12 and realize that this can also be further divided, dividing both the top and bottom by 3. 9 divided by 3 gives me 3, 12 divided by 3 gives me 4. Now I cannot divide either one of those numbers by anything, and that is my ultimate simplest form by using my greatest common factor, which was the 4 times the 3, which was then 12. Remember that you must divide the top and the bottom by that same number, that greatest common factor. As I think about how reducing fractions can ultimately give me a strong connection, I think about having measurements and needing to simplify measurements so I can better make comparisons about what's bigger and or what's smaller. And of course, when we have large numbers and how to make sense of those large numbers, reducing fractions is always a valuable tool.